So in this recording, I'm going to go over the functions and their inverses. This is Unit 2, Section 7. Our objectives are to find the inverses of functions. The way we do that is to write the rule for the inverse of a function. So you exchange the x and y, and then you solve the equation for y. So we're going to work through these together. Also, we can check our answers by putting the inverse in for x in the original function. So if we get x, then the inverse is correct. We're going to do all of this together. So first of all, there's some steps that you guys need to take. So we're going to replace that f of x there with a y. That's the first thing we're going to do. So we're going to rewrite the function using y instead of f of x. Then we're going to switch the x and y in the equation. So where the x was, we're going to put the y, and where the y was, we're going to put the x. Now we're going to solve for y, which means we got to get everything else that's on the right side of that equal sign over to the left. So we're dividing by 2, and the opposite of division is multiplication, so we're going to multiply by 2 to get rid of the 2 that's in the denominator. That brings us to this point. Then we're going to subtract 4 from both sides because 4 is being added to the right side. So we're going to subtract 4 from both sides. That's going to give us 2x minus 4 equals y. This is our inverse function. So what we can do with this right here, this 2x minus 4, is we can put it back up there in that x up there. And if we get x when we do that, that's going to tell us that this is indeed the inverse. So to check that, that's exactly what we're going to do next. So notice what I did. I put the 2x minus 4 right here where the x was. So minus 4 plus 4 is 0. That's what I have over here. So that's going to leave us just with the 2x over 2. 2x over 2. And 2 divided by 2 is just 1. So we did get x here. So we did verify that that was the inverse. That 2x minus 4 was the inverse of x plus 4 over 2. All right, our next one. We're going to find the inverse of f of x equals negative 5/3 x minus 25 over 3. Here again, the first step we're going to do is we're going to replace this f of x with y. That's always going to be our first step. Then we're going to switch the y for x and the x for y. That's always going to be our second step. Now, when we have a denominator like this, y'all, I know how much y'all don't like fractions, so we're going to get rid of it. So to do that, we're going to multiply both sides by 3. So we're going to multiply the 3 times the x over here, and we're going to multiply both of these. Now what that's going to do is the 3 here is going to cancel out both these 3's in the denominator. So that's just going to give us a pretty simple equation now. So again, our goal is to get y by itself, so we're going to add 25 to both sides because we're subtracting it. Opposite of subtraction is addition. Excuse me. And then our next step here is, again, we're trying to get y by itself, so we got it. That's being multiplied. Negative 5 is being multiplied by y, so we're going to divide both sides by negative 5. And when we do that, and we can simplify this, so this can be negative 3/5 minus 5, right? Because when this negative 5 is going to go to both terms there, okay? So that is our inverse. Once again, we're going to take this inverse and we're going to put it in for that x right up there. So that's what we're going to do next on the next slide, okay? So maybe, I don't know why this is coming in like this, but that was our original equation, and we're going to put that equation in for that x right there. So notice right here when we do this, these negative 5/3 times negative 3/5, that's going to cancel each other out. Y'all see that? And then, excuse me, when we multiply the negative 5 times the negative 5, that's going to be negative 25, or positive 25 over 3, right? So that's what we're going to get. So when we do this, we're going to step it out here. Again, notice here, that's going to cancel each other out. So that's just going to leave us with 15 over 15, which is x. And then we got negative 5 times negative 5. That's going to be positive 25 over 3. So then we have x is x minus minus 25 over 3 plus 25 over 3, right? We got that minus right there, and then we added this one. So these two are going to cancel each other out, aren't they? So that gets us x again. So here's our next one. Now notice we have a squared here. Recall that to do the opposite of a square, we have to take a square root. If we have a square root, we have to square it to do the opposite, okay? So here, again, our first step, rewrite using y instead of x. So we're going to put the y where the f of x was, right? And then we're going to swap the x and the y. Now, we got a squared up here. So to get rid of that, we're going to have to create a square root. So we're going to have to take the square root of both sides. So that's going to be our next step here. See that? We took a square root of both sides. Now what happens here is the square root and the square cancel each other out, okay? So what we're going to see in our next step is plus or minus the square root of x equals 1/2 y plus 2. Again, the square and the square root cancel each other out. So once again, we're going to subtract 2 from both sides. That's what I did here, subtracted 2 from both sides, right? Then we're going to multiply both sides by 2 here. Notice this. So the reciprocal of 1/2 is 2. So we're going to multiply both sides by 2. And when we do that, we're going to end up with f of x, the inverse of it, is 2 times plus or minus the square root of x minus 2. So once again, we're going to take this equation right here and we're going to stick it up there in that x, okay, to check it. So let's do that. There's our original equation. We're going to put our inverse right there where that x is. So that's what I did. I put it right where the x was. And you should see pretty quickly that 1/2 times 2, the 1/2 times 2, that's 1, right? And then we got -2 plus 2, that's 0. So that's just going to leave us plus or minus the square root of x squared. Again, remember square root, if we square root, they cancel each other out, so we're just left with the x. All right, so this you try. I would like you guys to try this and then come back to me when you're done. So go ahead and pause the video, attempt to do this problem on your own, and then let's come back and check it. Okay, so now, again, once we're going to rewrite the equation with the y, where the f of x was. We're going to swap the x and y. And you should notice that we're subtracting 1 here, so the opposite operation would be adding 1 to both sides, right? We have a square root this time, so the opposite operation of a square root is squaring. So we are going to square both sides. When we do that, the square root and the square again cancel each other out. So we're left with y minus 6 over here on the right. So we're going to do the opposite operation of that. Subtracting 6 would be adding 6 to both sides. And that is our inverse right there. The inverse of square root of x minus 6 minus 1 is x plus 1 squared plus 6. So once again, we're going to take this whole function right here. We're going to put it up there where that x is to check it. Okay, so we're going to put it right there where that x is. That's what I did. Once again, notice here we got 6 minus 6, so that's 0. So that's going to leave us the square root of x plus 1 squared. Again, the square root and the square are going to cancel each other out, right? So that's going to leave us with x plus 1 minus 1. Well, obviously 1 minus 1 is 0. So here's our next one. This one, notice we have h of n and n. I'm still going to replace them with x and y because my brain works that way. So I'm just going to put the y here and the x there. Then I'm going to swap them as we've been doing. Hopefully you see we got to get rid of that positive 2. The opposite operation of adding 2 is subtracting 2. Then we have a cube root here. So aren't we going to have to cube this up here? That means we got to cube both sides. So that's exactly what our next step is. Again, when we have a cube root and a cube, they're going to cancel each other out. So we're going to be left with y minus 2 over here. We have a subtracting 2 here, so we're going to add 2 to both sides. And that is our inverse function for example 3. I'm going to check it again by plugging it in there. We've got our plus 2 and our minus 2. That's going to be 0, right? We're going to take the cube root of n minus 3 cubed. These two are going to cancel each other out. So we're going to be left with n minus 2 plus 2. And obviously negative 2 plus 2 is 0, right? So that's n. All right, here's our last one. Pause me again, go do this, and then come back and let's check it. Okay, our first 2 steps, rewrite with y instead of h of n, and x, right? Okay. Switch the x and y in the equation. That's what we did here. This time, you should recall that if we have a cube, the opposite of that is a cube root. So we're going to take the cube root of both sides here. When we do that, these two are going to cancel each other out. So we're left with y minus 1. And we got the cube root of x over here. The opposite of subtraction is addition. So we're going to add 1 to both sides. There is our inverse function. And to check it again, we're going to take this answer, we're going to put it up there in that n. So that's what I did. Took that answer, put it up where the n was. We subtract 1 from 1, we get just the cube root of n cubed, which is n.